Okay, I'm going to start with number 5 on the sample practice exam. Let's see, use the given data to find the best predicted value of the response variable. So let's see, where did I start with here? It's a test at the 0.01 level. So I started with my null hypothesis, my HO, my rho equals 0, which means no linear correlation. My H1, rho does not equal 0. I have alpha equals 0.01. My test statistic, let's see. Actually, in this case, I didn't have to do that on this one. I was given some information. So I was given that my R equals 0.708. I'm given that there's 13 pair of data. So I said N is 13. So with this information, I can also find out with the alpha and the N, I can go to table A6, alpha is 0.01, N is 13, I get plus or minus 0.684. This is my critical value R. And then I compare that to my test statistic R. So I will get my test statistic R of 0.708 is greater than the critical value. And when that happens, I reject the null. I reject that there is not a correlation. So, which implies there is a correlation. Okay, I'm also given a regression equation. Y equals 55.8 plus 2.79x. Okay. Now, because I rejected HO, that implies that there is correlation between the two variables. So therefore, this equation, the regression equation, is a good model to use. So if I'm asked what's the best predicted value of y if x equals 3.6, then I can plug it in and get 55.8 plus 2.79 times 3.6, and I got 65.844, which is answer C. Now in this case, they also gave me the mean value for y, and that's 71.125, and that would be on page 521. I would use that chart at the top. If the regression equation is a good model, which it appears to be, then I want to go ahead and use it and plug the x value in. If this were not a good model, then I would take the mean value. Regardless of the value of x, I would always get, this was 3.6. Regardless of the value of x, I would always use this as my expected value for the y. Okay, on to number 6. Okay, I'm given the data and I'm asked to find regression line. So I did my x, I made an L1 with the 5 values, 6, 8, 20, 28, 36, and then my L2 is 2, 4, 13, 20, and 30. So I entered the data and did the two lists. I did a linear regression t-test, and using my A's and B's to plug in, I got y equals minus 3.79 plus 0.897b. I think this was the A value, this is the B value that prints out in your calculator, and up above it says y equals a plus bx. And you did this on some of your homework problems, so I think this was section 10.3. And then the next part, number 7, says, what if there's an outlier or actually, we don't know if it's an outlier yet. You want to add a new point, 31 and 50. So now I'll go back to my L1 and I'll just add a 6 value at the bottom. 31 for X and a 50 for Y. So 31 goes in the L1, 50 goes in my L2. So now they each have 6 values. And then I went ahead and did the linear regression t-test again. If I plot it, I get something like this, roughly like this. And this is the new point I added. And then when I did my regression line, I got y equals minus 6.373 plus 1.2189x. Now when we do the graphs of the line, this first number is called the y-intercept. So if I'm drawing the graph of a line and it's minus 6 something, it's going to come down here. That's where the line crosses the y-axis. This is the y-axis. My slope, if this is positive, it goes upward to the right. So this is positive, a little over 1. So it's kind of just up 1 over 1, basically. That would be similar to what that line would look like. So for both of these to compare, it asks you what are the new slope and intercept values. So my new intercept is the minus 6.373. My new slope is the 1.2189 compared to how I had the 0.897 before. And it asks if that new point is an influential point, outlier, both, or neither. Well, it's definitely an outlier. It sticks up out of the way. But I'm saying it is not an influential point. If you look up the definition for what the influential point does, oh shoot, I don't have the page here, but there was an example of influential points. If the influential point dramatically changes the slope of the regression line, so if instead of a regression line like this, you get something like this, then that new point is also considered influential. In this case, just eyeballing these numbers, it makes the slope a little steeper than what it is, but I don't find that to be a dramatic change. So therefore, I chose answer D, outlier only.